Welcome to the third lesson of our WireGuard VPN course. In this lesson, we are going to explore the site-to-site configuration. Especially, we are going to make our first site-to-site configuration from London to Paris, from London office to Paris office. In our configuration, Paris office is going to behave as a WireGuard VPN server, and the London office router will behave as a WireGuard VPN client. On the previous lesson, we already explored the configuration of our ISP router, so we are not going to explore it again. In this lesson, we are going to explore the current existing IP address configuration of London router and Paris router, so that later on we can build a VPN tunnel between Paris and London router and test the VPN tunnel functionality. Let's start from the London office. Let's open the Winbox. Let's find our ISP router and try to connect it via Roman. Say connect to Roman. And as you can see, our ISP router can see London office and Paris headquarter office routers. Let's connect to the London router first. And as you can see, we have connected via Roman, via network of 192.168.13.0. I have a computer somewhere here which is able to connect to the ISP router, and then via Roman technology I'm able to connect to London and Paris offices. In order to activate Roman on REST routers, including the ISP, you have to go to Tools, Roman, say Enable, and it's better to put some secret. I put a secret as number 1. This secret has to be same on all the routers which you plan to communicate with the Roman technology. Plus, in the ports, you should select all ports in our lab. All ports means ports Ethernet 2, Ethernet 3, Ethernet 4, and Ethernet 1. In this case, all these routers will be able to communicate with each other using Roman technology, and you will be able to access it via another computer on external network to the EVNG, and you would not need to connect via host only adapter, which is on your host machine where the VMware Workstation Pro is running with its EVNG virtual machine, so that in case this machine may be a little bit noisy or producing too much heat, you can install this machine some other location and connect to that machine using totally another computer like I'm doing here. Look, I'm connecting to 13.68, which is another computer where actually the EVNG is installed on the VMware Workstation Pro and it is running there. And if we check my current IP address, let's say IP config, I am on 13.71, which is another totally other machine, which is not on the server itself. How can we prove that we are not on the host only machine? Because this is the host only machine and this is the virtual machine of the EVNG which is running. Let's also say command line interface and let's check the host only machine IP address configuration. As you can see, the host only machine has IP address of 13.58 and my machine has IP address of 30.71. So I am not located on the host only machine. But host only machine is working near me. It's a compact server PC with 64 GB of RAM. But my client machine, which I'm working from, has only 8 GB of RAM and I'm totally happy with it. It's not making any noise, it's not overheating, it's fine. So after we understood how we can connect to the Mikrotik routers via external network using Roman, let's start from the London router configuration. Let's explore what are the interfaces available here. We can see that we have a bridge with 1, 2, 3, 4 interfaces. Let's open the bridge. This is a London office router. Bridge has 2 ports, 4 and 2. 4 and 2. Let's look on the diagram. 4 and 2. So as you can see, port 4 is connected to some kind of PC, which is called London Win 11 PC 01. Port number 2 is not connected to anywhere. Port number 3 is connected to host only, which I have used to initially set up the Mikrotik router via host only interface on my host computer where the EVNG is running. And the Ethernet 1 is looking into the internet. So let's continue. Let's look into the IP addresses. We have the IP address of 172.1.1.2. Let's compare. 172.16.1.2. So it's a one interface IP address. Let's see where it is assigned to. IP address. As you can see, it is assigned to Ether1 and it's matching our Ether1 configuration 1.2, and this one is also 16.2. /24 subnet mask. Let's see. This is the network, this is the interface, this is the IP with the mask. Then we have one more IP address on the bridge interface. It says 192.168.1.1/24. So this is this bridge interface, which has 2 ports, port 4 and 2. 4 and 2. 2 is not connected to anywhere, but 4 is connected to this Windows PC. And this interface or this bridge has a DHCP server enabled. If we go and look to IP DHCP server, we can see that it is running on some interface, which is bridge 1. It has a lease time of 30 minutes. It has a pool. It's assigning this network 168.1. And we have a one lease, which is this computer, London Windows 11. And the DHCP server has assigned the IP address of 1.254. I think the DHCP server setup is not a complex topic, but you can do it using the wizard, DHCP setup. You can specify the interface, then click next, activate the necessary parameters of the network, and then the setup will be finalized. It's very easy, step by step. It's not a complex wizard. I hope you already know how to do it, so we will not focus on this part. Normally from the Mikrotik RouterOS, if you buy it from the market, you will have 4 interfaces. If you have a 5-port router board, port number 1 is adjusted to expect the DHCP server from the internet. Other 4 ports are joined into bridge, and this bridge has a DHCP server which is distributing IP addresses on network of 192.168.88.1/24. I was trying to simulate the small size router board, which has 4 to 5 interfaces, so that in case you are using real hardware to emulate the network, you can use the configuration which is presented here also for those router boards. Let's check how does the London office is getting internet. If we check the IP DHCP client, it is enabled, but it cannot get any IP addresses, so we can disable it. Why? Because I actually set the IP addresses manually. If you look here, the Ethernet 1 was set manually, the IP address of 192.168.1.2/24 on the Ethernet 1. So it is not getting the IP address from the DHCP server of the ISP, because in my configuration, the ISP doesn't distribute any IP addresses on its interfaces to its clients, so that you have to adjust on the client side the IP address configuration yourself, so that we adjusted the IP address configuration. Then in IP routes, we have set the default gateway. It is also static. We set 0.0.0/0 is available via 172.16.1.1, which is this port on the ISP. And the distance scope, target scope, and other parameters are default. We didn't adjust them. Then I added for the Mikrotik itself the DNS, IP DNS, and I have set the Google's A.A.A.8 IP address. I didn't activate the allow remote request, so our current router configuration is not accepting any DNS requests from the local clients like this Windows PC. Windows PC has its own DNS configuration, so it doesn't need any DNS server running on the Mikrotik in our configuration. Let's a little bit expand our Winbox so that we can see what else is available on the Mikrotik, on London office Mikrotik. As you can see, I have assigned Ethernet 1 and bridge IP addresses only. We have one disabled unknown interface, which we will return later on. Now I want to explore the interfaces configuration. We have LAN interface and WAN interface lists. LAN interface list has a bridge inside. We have one disabled list, which we will activate later on. And we have one WAN list with Ethernet port added there. So in LAN list, we have bridge. In WAN list, we have Ether1. We are going to use these lists in the firewall configuration. So let's open the firewall. In the firewall, we see 1, 2, 3, 4, 5, 6, 7, 8 rules. They are going in sequence. Actually, all those rules come by default on the router board when you buy it from the market. But as this is the virtual machine, I have to simulate a router board. I even deleted some of the rules which we don't need here, like fast track, because we are not going to use it here. So I have implemented similar rules, even less, which will protect our router from external threats. So let's analyze the firewall configuration which we have implemented. First one is the input chain. Everything what comes to the router, established, related, or untracked, we do the action of accept. The second rule says anything that comes with invalid packet type, action is dropped. Some malformed packets, unknown packets, not expected packets will be dropped. Let's see the counters here. We see that no drops so far, but we have some established related traffic, most probably coming from this computer which is running now. If we open it, we can see that it's already functional. Let's log in there. Test 1, 2, 3. It actually has acquired the IP address of the 254, which we have just seen. And most probably, it is making this kind of traffic. The third rule is input chain ICMP. So we accept to the router from any port, one port, LAN port, whatever port, action accept. We accept all kind of ICMP packets. Next rule is input destination port 53, not from LAN, action accept. We are actually accepting the requests on the DNS server of the Mikrotik, which are not coming from the WAN interface. Even though we are accepting them, our IP DNS configuration is not set to accept it. So this is actually unnecessary rule, which you can disable in the current setup. But if you are going to use your regional, let's say London router as a DNS server, then you should leave this rule active. Then the rule number 4 is drop. To the input, everything what is not coming from the LAN, action drop. This rule actually protects your router from all kind of malicious LAN access. So let's say if you have some Winbox available from the LAN, it would not be available from the WAN, because this rule will block it unless you add a specific rule which will accept it. Next rule is in the forward chain. So anything which is passing through the router with a state of established, related, untracked, we do accept. Then we have a drop rule. Anything which is passing through the router with invalid type, we drop it. And the last rule, also the forward chain rule, anything what is coming to the interface 1, in our case it is Ethernet 1, which is new and not destination knotted, we don't have a destinated knot rule for it, we are dropping it. So this is also a protection in the forward chain for your local network. And we have a one NAT rule. This one NAT rule shows that the out interface Ethernet 1, which is our internet connection, in the chain source NAT, do the masquerade so that we can do the masquerade of this local area network into the internet service provider network, so that internet service provider network doesn't know about our 192.168.1.0/24 network. Why? Because we are masquerading or source NATing or port NATing. Depends on which terminology you are adapted to use. Let's analyze the far end side which we are going to connect. In our case, it's Paris headquarter network, which will be in the role of our WireGuard VPN server. What kind of configuration does it have? So we say Paris network, connect. Let's start from the firewall. So firewall is totally same. Just we have one more rule here for the UDP input in the destination port 443. Action is accept. What does it mean? It means that we are on the input chain is expecting UDP packets on port 443, which we are going to use for our WireGuard server. This rule is set but not enabled. Let's enable it. We have one more rule here, which can be used to accept Winbox connectivity from the internet side, which is not active. So input chain TCP port 8291 in interface 1 action is accept, but it's not enabled. It means from the one interface side we are not able to connect via Winbox with the current setup. In the NAT rule we have a similar configuration. Just instead of out interface ether1 we set out interface list 1. Action is masquerade. Let's check the interfaces. We have bridge interface, Ethernet interface, and one unknown interface which is disabled. Let's check the bridge interface. Bridge interface has ports 2 and 4. And if we see on our design, it is 2 and 4. 2 is not visible here, but 4 is connected to the server. So on London office, 4 is connected to the computer, Windows 11 Pro. And here 4 is connected to the Windows Server 2025 and should have a network on that bridge 192.168.3.0/24. Let's check. Paris headquarter bridge IP addresses. IP address on the bridge is 192.168.3.1 and the DHCP server is also running on that bridge interface, similar to London site configuration, just the IP address is different here. As you can see, everything is same, just the network is different. And the interface subnet is also different, which is set manually, 192.168.3.2. Let's check. As you can see here, 192.16.3.0, 192.16.3.2, 2 and 1 is the ISP. Let's check the routes, IP routes. We have a route, not this one, default route, 0.0.0.0.0/0 is available via 172.16.3.1, which is gateway, which is the ISP router gateway, this interface. Then we have an IP address dynamically assigned on the routes from the IP interface list. It's not interesting for us now. Also, if we check tools ROM on, it's also enabled with a secret of 1, and ports, all ports are not forbidden. That's why we are able to access the Paris router remotely. If we look into the WireGuard, we don't have any configuration on the Paris site. If we look into the London office, WireGuard, we also don't have any configuration. So now we are going to start building our WireGuard VPN tunnel between London and Paris sites. So first thing that we are going to do on the London router, we are going to create a WireGuard interface. Click on plus and let's call it from London to Paris, and this is our client. Let's say apply. We will leave the M2 size default 1420, and as you can see, some kind of private and public key was generated. If you want to see what is the private key, you can go to the settings and remove tick from the high passwords. In this way you can see the private key also. We are totally fine with this. Now let's go to the Paris router and also create server side WireGuard interface, and we call it WireGuard 1 server. Let's say apply. Let's also see the public and private keys. Normally we don't need private key, so let's hide it so that we don't confuse. So now we have interfaces created on both sides and we see their public IP addresses. We would need the opposite side public keys to build or to establish the WireGuard tunnel. So let's copy the public key of the Paris headquarters. Say copy. Go to the London site and create a peer. Peer means the remote connection settings. We can give a name to our peer. Let's say it to Paris server. We should choose the interface which we are going to use for this connectivity. In our London office configuration, we just have only one interface. That's why it was selected automatically, and we don't need more than one. Then we should paste the public key here from the remote site where we are going to connect to. And this is the public key of the Paris WireGuard interface. Let's paste. It's ending with SBC equal. Let's check. Yes, it was ending with SBC equal. So this is the right public key. Then we should specify the endpoint. Endpoint is the server's IP address. In our case, the server IP address is Paris headquarter router 1 interface. Paris headquarter 1 interface IP address is 172.16.3.2. So we say 172.16.3.2. And we should specify the endpoint port. We have set on the Paris router that we are going to expect the connection on the port 443 UDP. So that we specify here 443, there is no need to specify TCP or UDP because WireGuard is working only on UDP with the current implementation. In the allowed address list, we can leave default. Let's use just IPv4 0.0.0.0/0. On the Paris side, we will have a little bit different configuration, but currently we are focused on the London side peer configuration. Then we can use or we may not use the pre-shared key. For additional security, the pre-shared key is preferable. Let's say auto so that the key can be generated by the Mikrotik. Let's say apply. And as you can see, the key was generated automatically. We can copy this key and paste it on the Paris site. Let's check. Paris site. Before we paste it on the Paris site, we have to create the Paris peer. So let's paste it here, and then we fill in other information on the Paris site. So Paris site peer will have a name of, let's say, peer for London office. So this peer will have a synchronous configuration with the peer in the London office. The WireGuard interface that we have created previously on the Paris headquarters site, we will use it. We don't need anything else. Public key. Here we should paste the public key of the London WireGuard peer. Of the London WireGuard interface, not peer. Let's go to the London. Let's open the interface public key. Let's hide anything else. We need this one. Let's say copy. Let's go to Paris and paste its public key. The private key we don't need. The endpoint we don't need because we are the server. We are expecting for somebody to connect to us. We are not going to dynamically connect to any other peers or whatever endpoints. That's why we should put here tick responder. If we are server side, we are expecting the connections to us remotely request to build a tunnel. We should put a tick here as a responder. It means that we are the server side. We are not making our request based on the endpoint. We don't specify any endpoint and endpoint port configurations. In the allowed address list, we should specify that we are allowing IP address from the remote peer on the IP address of 10.10.10.3/32. And we can maybe add one more network, which is available on the London site, which is 192.168.1.0/24. So this should be the remote interface on the WireGuard VPN network, and this will be the remote network which is available on London local area network. Pre-shared key which we have already set, public key we have already set. Maybe we can specify here the keep alive of, let's say, 20 seconds and say apply. Configuration below the responder is not necessary in our case. So we can go to the London site and maybe also specify the London site. This is the London site. We can specify the peer keep alive. We can also set it 20 seconds. So every 20 seconds, these two peers will send each other some small packet in order to say that, hey, are you alive there? Everything is fine. Or if there is a NAT between these two routers, let's say we have a service provider which is making a carrier grade NAT or some 4G or 5G provider, we can use a keep alive packet so that this NAT doesn't die. We are not putting a responder tick here because we are not a server. Upon the successful activation of the tunnel, you should see here some statistics on RX and takes packets. And you should see here a last handshake. We don't see the RX statistics. Let's see why. Let's go to the Paris office. We also don't see anything here. What we have missed is most probably we have missed to set the port 443 on the server side. Currently it's set to 4371, which is the listening port, but on our firewall, which we set on Paris site, we are listening on the WireGuard VPN except UDP port 443. The foreign side is sending the packets, the London router is sending, you can see the counters here, but the server side is expecting them on 4371 or 4371, and then we should change it to 443. Say apply, and let's see if the peer status has changed. Now you can see there is RX and takes traffic started to go bidirectional, and the last handshake counter is activated. Let's see what is going on the London side. London side also has last handshake started and RX and takes counters started. Okay, what is missing in our configuration is IP addresses that we have to set to our WireGuard VPN client interfaces. If we go to the London site and see the IP addresses configuration, we see that the WireGuard interface has no IP address set. According to our design, it should have the IP address set to 10.10.10.3/24. Let's do it. Oh, London. This is London Mikrotik. Let's say 10.10.10.3/24 on interface WireGuard from London to Paris client. Let's say apply and let's say enable. Now we have set the 10.10.3/24 IP address on WireGuard interface on this logical interface, which is shown as red tunnel. The same we have to set 10.10.10.1/24 on the WireGuard tunnel interface on the Paris side. Let's do it. Paris side IP addresses 10.10.10.1/24 on WireGuard server. Let's say apply and OK and enable. Now the tunnel interfaces are set. What is missing? The missing part is the routes. So let's go to the London side. If we want to reach from this network to this network 192.168.3.0/24 via the WireGuard VPN tunnel, we should say that this network is available via this tunnel. How can we do it? We should say IP routes, and I have specified here the road. You should say 192.168.3.0, this network, is available via 10.10.10.1 via this tunnel interface. Distance, scope, target, rest parameters are same. We should say OK. In our case, it is already was set, but it was disabled. Let's enable it. So now we have a route set that if we want to reach 192.168.3.0/24, we should use this gateway, 10.10.10.1, or the far end side of this tunnel. The same we have to set on the Paris side. Let's check the Paris side. Paris side. Paris side, let's say IP routes. Let's minimize it. Minimize this. We should say that if we want to reach network 192.168.1.0/24, 192.168.1.0/24, we should send the packets to the gateway or to the IP address 10.10.10.3 or this tunnel interface, which is already running. And we say OK, and let's enable it. Now these two networks know how to send packets to each other using which tunnel interfaces. Let's check if the tunnel is up and running. We will connect to the London PC and open the command prompt and say ping. And we are going to ping this interface. So from this London computer, we are going to ping this server. So we will check that the tunnel is working. Ping 192.168.3.100. And as you can see, we can ping it. Let's trace route to see how the packet is going. Trace route. As you can see, the packet is going to the 192.168.1.1, which is gateway of London. Then it goes to 10.10.10.1, which is remote far end of the Paris office. And then it reached the server side. Let's see on the interface if it's passing through the WireGuard interface, let's say from the London side. Let's open London Mikrotik. Let's open the WireGuard interface and let's see if any traffic is passing through it. For example, from here. Let's say ping, and let's say with the packet size of L1000, and let's send some traffic. As you can see, the traffic of 8.5 kilobits per second is being sent. Let's send it constantly. As you can see, the traffic is passing through. To achieve additional proof, we can double click on the interface and say torch. And this torch will show us that we have a ICMP from source 3.100 server side. Destination 1.254 is responding with this TXRX rate. So the torch can see the traffic on the ICMP on our router side. So once again, we have proved that the traffic is passing through the interface. So our tunnel is running. The ICMP packets which are passing through this tunnel are encrypted. One more point which I want to discuss here is that in case you have a Winbox, let's say Winbox, on your London Windows 11 Pro PC, and you want to connect to the Paris office tunnel interface from London office to manage this router, you have to have on the Paris office the following rule. You should say that the Paris headquarters LAN interface list should contain also WireGuard server interface. So whatever comes to WireGuard server on the input direction should be allowed. Why? Because here we have IP firewall rule, which says, not this one, but this one. Input chain, anything that is coming to the input not from LAN interface, action is dropped. So because we have just added from the interfaces to the interface list that the WireGuard interface is also part of our LAN, the request which will be coming from remote routers to access the Winbox management interface using username and password will be allowed. The same we should do on the London office side. Let's find the London office. This is Paris, this is London. So on the London office side, you should also go to the interface lists and add to the LAN the WireGuard 1 from London to Paris client and enable it. In this case, if let's say this server computer has a Winbox client software, he will be able through the tunnel connect to the tunnel interface or even to 192.168.1.1 bridge interface from the Paris server 2025 to the Winbox to manage it. Why? Because in the firewall of London, we have also a rule that says that we are only accepting input connections to our Mikrotik from LAN interface. Anything else we are dropping. You see, it says here input. If it's not LAN, drop. If it's LAN, it will be accepted. It's not only for Winbox, it can be anything which is accepting connection on the LAN interface. Even it could be the DNS server. You can point your server, let's say, to the DNS server of this Mikrotik, and it can send a request through this tunnel and resolve the DNS queries on the London office DNS server in case you need it. I don't say that it is mandatory, but in case you need it, this rule is necessary. So now we have a fully functional VPN tunnel. Let's check again if this is the reality by opening the server side. And let's try to ping the Windows 11 Pro computer from the server side. If it's pingable, if it's trace routable, then the tunnel is working from the other side also. Let's wait for the server to boot up. Let's say CMD. Let's ping the network which is located on the London site. 192.168.1.254. Oops, not 2. And as you can see, it can ping it. Let's trace route to the same IP address. As you can see, the trace route is working from 192.168.3.1, which is this interface. Then it goes to 10.10.10.3, which is this interface, VPN interface on London router. Then it goes to 192.168.1.254, which is the IP address of this London Windows 11 PC. Let's check if we can ping the 10.10.10.3 also, the remote VPN interface IP address. 10.10.10.3. We can ping it. Let's check if we can ping. Let's check if we can ping the server VPN interface. 10.10.10.1. We can ping it. So all kind of routing is enabled. The tunnel between this London office network and this Paris office network with the server is functional. All traffic which is going between these two networks is passing through the tunnel. We can even check from here that if the network that we are going to ping is outside of this tunnel scope, it will go to the internet. Let's check. For example, let's say ping resource, which is in the internet, 192.168.11.1. It is pingable. Let's trace route it. Oops. As you can see, it goes to 1.1, which is this interface, then goes to 16.1.1, which is this interface, then goes to 13.1, which is internet globe, then it goes to 11.1, which is even further. So why it goes like this? Because if we look into the London routing table by accessing IP routes, it says that network 10.10.10/24 is on the WireGuard interface tunnel, fine. Network 192.168.3.0 is behind this interface, which is this interface or this interface. It means that in order to reach 3.0, we should send packet here, and this router will route it to this network, 3.0. Anything else which is not matching should go to the default gateway, which is 172.16.1.1. Default gateway is this router, and this router, if it sees that the packet is not applicable for any other networks which it is connected to, it will send it to its own default gateway, which is this network, 192.168.13.0/24, and then the next router will send it further to the internet. Hope it's clear. This is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment sections of the video. On the next lesson, we are going to build a tunnel between Berlin office network and Paris headquarter network. And then we will also build an hub and spoke topology where we can route the traffic not only between Berlin office network and Paris office network, but also between Berlin office network to London office network via Paris headquarter office network. Why we may need it, we will discuss on the next lesson. See you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.